Hello and howdy once again, ladies and gentlemen. We're looking at question number 5 on the 2005 Fermat paper. A Fermat coin rolls from P to Q to R as shown. If the distance from P to Q is equal to the distance from Q to R, what is the orientation of the coin when it reaches R? So I'm going to copy this picture over, and this is sort of just a question you need to talk yourself through. There isn't a whole lot of math that we could be doing. You could probably math it up a little bit, but it's a lot faster just to sort of intuit it. So to explain it to yourself. Okay, so let's call the common distance here x. So what happens in rolling distance x, or perhaps a little easier way to understand it is by rolling distance x, the coin's F, the F on the coin, has, well, what has it done? It started standing up, and then it's sort of fallen on its back almost. Okay, it's gone back this way by 90 degrees. The F has rotated counterclockwise by 90 degrees. He's lying on his back. So if that's what happens when it rolls distance x, that's the same thing that's going to happen when we roll distance x again. Okay, so we're going to roll another 90 degrees clockwise. And now the top part of the F is going to be at the bottom. And it's going to, instead of, so the branch of the F pointed this way, then it pointed up. Now it's going to point this way. And we can complete our F from there, and that's the picture that we need. So that's C. And just by expressing what the coin does, since it's the same distance, it'll roll the same way. So we don't know if it just, did it do sort of a single loop and then it didn't quite complete itself, or did it only roll a quarter of the way, or was distance x long enough for it to loop several times? We don't know. But the point is, going distance x produces a result. We produce that result again by rolling another x. All right. So that was C on question number 5. We'll flip the page in anticipation of our very next question, question 6.